NASA just announced the discovery of 500 new planets.
Astronomers spend lifetimes trying to search for Earth-like planets.
Astronomers have discovered the nearest potentially habitable planet outside our solar system.
Out in space, a new world calls to us. Astronomers have found a super-Earth, hiding secrets and maybe even life. It circles a far-off star, sparking dreams of what's out there. Could this planet be a second home for us, or hold dangers we've never seen? Let's explore the new super-Earth that could be a habitable world. Chapter 1. Welcome to TOI-715b. The universe is an endlessly interesting place, full of amazing things to see and mysteries that keep us wanting to learn more. It's incredibly big, and it's home to a huge variety of planets that never fail to amaze us. One of the latest exciting finds is a planet called TOI-715b. This planet is a bit of a heavyweight, being bigger than Earth but not as big as the giants like Uranus and Neptune. It goes around a type of star called an M-dwarf, which are pretty common in our Milky Way galaxy. These stars aren't as big or as hot as our Sun. TOI-715b is not too far from us in the big picture, sitting about 137 light-years away. That sounds close by cosmic standards, but it's far beyond where we can travel with our current technology. There are several reasons why TOI-715b catches our attention. For starters, it's about 1.55 times the size of Earth. This means it could have a very different weather system and land features from our planet. It's located just the right distance from its star to potentially have liquid water, right in the so-called habitable zone, or Goldilocks zone. This zone is the sweet spot where it's not too hot and not too cold, which might allow liquid water to exist. And since water is essential for life as we know it, finding a planet in this zone is really exciting for scientists and anyone interested in space. The idea that TOI-715b might have liquid water is still just a guess, but its position makes us hopeful. What's also thrilling is that there's another planet being looked into in the same system that might be the smallest planet we've found yet that could be in a habitable zone. This is being studied thanks to a mission called the Transiting Exoplanet Survey Satellite, run by NASA, which is all about finding planets outside our solar system. If this other planet is confirmed to exist, it could tell us a lot more about what kinds of planets could support life. This discovery highlights the wide range of planets out there and their potential to be habitable. Finding TOI-715b and possibly another nearby planet highlights the amazing work being done by astronomers and the power of the telescopes we use to look into space. These discoveries remind us how vast the universe is and its endless possibilities for finding new worlds. Each planet we discover brings us a little closer to solving the universe's mysteries and the chance of finding life somewhere else. As we keep exploring the stars, it's thrilling to think about what other secrets we might uncover. The discovery of planets like TOI-715b expands our knowledge and fuels our curiosity about what lies beyond our solar system. The chance to learn more about our universe and the possibility of life existing elsewhere keeps us eager to keep looking and learning. With the intriguing prospects that come with the discovery of TOI-715b, we're encouraged to dive even deeper into the cosmic wonders that await us. Chapter 2. Discovery and Secrets Unveiled. The study of stars and the planets that circle them is a subject that has captivated those who watch the skies for a very long time, especially the planets that go around smaller, cooler stars known as M-dwarfs. These stars, less massive and bright than our own Sun, are of particular interest because of the unique types of planets they host. Among these, a red dwarf star named TOI-715 is especially noteworthy for its role in hosting a planet known as TOI-715b. This star, which is much smaller than our Sun, having only about 1/4 of the Sun's mass and size, shines with a dim light that draws the attention of astronomers and space enthusiasts alike. TOI-715b orbits its host star, TOI-715, every 19 days, a much shorter period than Earth's orbit around the Sun. This quick orbit is due to the planet's close proximity to its star, which is much closer than Earth is to the Sun. Yet, intriguingly, TOI-715b sits within what scientists call the conservative habitable zone of its star. This zone is considered the ideal range from a star where it's possible for a planet to have liquid water on its surface, a key ingredient thought to be necessary for life. Studying systems like the one that includes TOI-715 and its planet, TOI-715b, opens new doors to understanding how planets orbit and the potential conditions on these worlds. Despite being so close to its star, the fact that TOI-715b is within the habitable zone adds an exciting aspect to the quest for finding planets that could support life. The characteristics of TOI-715, being smaller and cooler than the Sun, yet capable of having a planet in a habitable zone, highlight the diversity of planetary systems in the universe. It suggests there could be many possibilities for life-supporting conditions outside our solar system, fueling the drive of researchers and space watchers to discover more about the vast universe around us. The concept of the conservative habitable zone is particularly thrilling because it suggests planets could exist in conditions suitable for life. The placement of TOI-715b in this zone raises many questions about its environment and whether it has the right elements to support life. The rapid orbit of TOI-715b around its star, completing a year in just 19 days, means it experiences seasons and years at a pace far quicker than Earth. This quick cycle and its promising location make TOI-715b a prime candidate for further study. Scientists are keen to dive deeper into the details of TOI-715b to expand our knowledge of the universe and the potential for other life-bearing planets. The role of M-dwarf stars like TOI-715 in hosting planets such as TOI-715b is a focal point in astronomy. These stars offer a distinct environment that might support life, albeit under conditions different from Earth's. The discovery of planets orbiting these cooler, smaller stars leads researchers to explore new directions in their search for life. It challenges previous notions of habitability and extends the search for extraterrestrial life to include planets around stars dissimilar to the Sun. Investigating TOI-715b, with its fast orbits and advantageous position within the habitable zone, provides a compelling example in the search for places where life could exist beyond Earth. This line of research broadens our understanding of the variety of planetary systems and challenges our ideas about what environments are necessary for life. It introduces the thrilling possibility that planets capable of supporting life might be found in various circumstances, including those orbiting stars very different from our Sun. As we learn more about the secrets of TOI-715b and its rapid journey around its star, our appreciation grows for the dedicated scientists and astronomers whose hard work and creativity bring these distant worlds into focus. Their efforts not only shed light on the mysteries of the universe, but also inspire us to think broadly about where and how life might exist beyond our own planet. This exploration into the cosmos, driven by curiosity and the pursuit of knowledge, continues to push the boundaries of what we know and opens up new possibilities for understanding our place in the universe. Chapter 3: Science Behind the Scenes. The story of discovering TOI-715b and learning about its characteristics is a fascinating tale of scientific adventure and breakthroughs. This exploration was thoroughly documented in a paper published by the monthly Notices of the Royal Astronomical Society, a prestigious publication in the science community. Georgina Dransfield spearheaded the research project from the University of Birmingham's School of Physics and Astronomy. Dransfield, along with her team, embarked on a mission to expand our knowledge of the universe by identifying and studying exoplanets, which are planets that orbit stars outside of our solar system. Their investigation sheds light on the distinct aspects of TOI-715b and integrates this intriguing planet into our broader understanding of space. The publication of their findings represents a valuable addition to the realm of exoplanetary science, the branch of astronomy that delves into planets around stars beyond the Sun. Utilizing cutting-edge observational methods, Dransfield's team was able to detect and analyze this distant world, thereby enriching our collective grasp of the vast universe. The techniques used by Dransfield and her collaborators represent the pinnacle of current scientific methods, involving sophisticated telescopes and space missions capable of peering into the depths of space to observe celestial objects from great distances. These innovative approaches enable the team to collect detailed data on the size, orbit, and even the atmospheric conditions of far-off stars and planets. Such achievements typically require combining observations from different instruments and applying intricate mathematical models to interpret the data that has traversed light years to reach Earth. Their meticulous work is part of a larger effort to catalog and study exoplanets, aiming to enhance our knowledge about the number of planets in the universe, their properties, and how they compare to Earth. The study of TOI-715b highlights the collaborative nature of scientific discovery. Specialists from various disciplines and parts of the world come together, sharing their expertise, tools, and discoveries to decipher the mysteries of the universe. The success of Dransfield and her team exemplifies the depth of human curiosity and our inherent desire to understand the cosmos at large. Their endeavor goes beyond simple observation. It involves inventing and refining new tools and methods to push the boundaries of our sight further into the cosmos. At its heart, uncovering TOI-715b and the innovative techniques that made it possible mark a significant leap in our quest to explore outer space. By pushing the boundaries of our knowledge and technological capabilities, groups like Dransfield's are mapping out the uncharted regions of the universe where planets like TOI-715b reside. Their dedication and revolutionary approaches are paving the way for future ventures that may one day answer the age-old question of whether there is life beyond our planet. This journey not only reveals new cosmic phenomena, but also moves us closer to comprehending the vastness and diversity of the universe. It offers insights into how life on Earth might fit within the grand scheme of the cosmos. As we learn more about science and find new planets, we start to wonder, could these far-off places be homes to life that we haven't discovered yet? Chapter 4: Habitable Worlds, Fact or Fiction? When we search the vast space for planets where life could exist, we pay a lot of attention to something called the habitable zone. Imagine an area around a star where the temperature is perfect, not too hot, not too cold, so water can stay as a liquid. This is important because for a planet to be seen as possibly livable, it must have liquid water. Scientists talk about a narrower part of this zone, named the conservative habitable zone, which is even better for keeping water liquid, which is crucial for life. Finding planets like TOI-715b in this special zone makes us very excited. Being in this zone means TOI-715b gets just the right amount of warmth and light from its star, making water flow and collect in pools. This is key because, as far as we know, liquid water is essential for life. So discovering planets in these zones gives us hope. It means these planets could support life and might even have life, perhaps similar to Earth's. This idea makes us think about the chance of other planets being homes to life, showing how much life could be out there in the universe. This zone is like the just right spot in space, not too hot or cold, perfect for water to stay liquid. This helps scientists look in the vast universe for places where life-supporting conditions might exist. Being in the conservative habitable zone, CHZ, doesn't guarantee TOI-715b or any planet has life, but it means we're searching in the right spot. This opens many possibilities for discovering life in the huge space. Using this principle, researchers can focus their search on specific areas that might have planets able to support life. Being in the CHZ suggests a planet like TOI-715b could have the right conditions, like liquid water, for life. While it doesn't prove life exists there, it's an important step in our search. It starts a detailed investigation into these worlds, making us curious about possible life forms beyond Earth. The idea of finding the just right zone not only helps narrow our search, but also inspires us to imagine the various life forms waiting to be discovered. With our curiosity about habitable planets growing, let's dive into the cosmic mystery that includes planets like TOI-715b and challenges what we know about where life could exist. Chapter 5. Exploring the Radius Gap Mystery. The radius gap phenomenon is a cool mystery we come across when looking at space, focusing on exoplanets. These are planets that orbit stars far away from our sun. It's like a big puzzle from space, and it gets really interesting when we talk about finding a planet named TOI-715b. We want to make this tricky subject easy for everyone to get. Imagine you're playing with a bunch of marbles. You have big ones and small ones. But when you try to line them up, you notice there's a certain size missing. It's like those marbles just don't exist. This is pretty much what happened to astronomers when they were looking at small, distant planets. They saw there was a weird gap in the sizes of these planets, like if there were missing pieces in a space puzzle. This gap, called the Small Planet Radius Gap, is like a space where we'd expect to find planets of certain sizes, but for some reason they're just not there. Then we found TOI-715b, a planet that fits right into this strange gap, kind of like that one marble you find that's exactly the size that was missing. This planet is about 1.55 times bigger than Earth, and sits right in the gap we were talking about. For scientists, TOI-715b is super exciting because it gives them a chance to figure out why this gap exists. Finding it is like adding a missing piece back into our space puzzle and helps open up new ways to understand how planets are made and how they change. Let's double that explanation to make it even clearer and more engaging. The radius gap phenomenon is like a big, mysterious game we play when we dive into the study of space, especially looking at exoplanets, which are planets orbiting stars way beyond our solar system. It feels like we're detectives in a cosmic investigation, and it gets even more thrilling with the discovery of a planet called TOI-715b. Our goal is to unpack this complex mystery and make it something anyone can understand. Now, think about sorting through a diverse collection of marbles. Among your collection, there are large marbles and there are tiny marbles. But as you organize them by size, you hit a snag. There's a specific range of sizes that's just not there. It's as if these marbles have vanished. This situation is very similar to what space researchers encounter as they measure and categorize the sizes of distant, smaller planets. They've noticed an odd gap, a range of planet sizes that should be there, according to our expectations, but is mysteriously missing, like puzzle pieces that have disappeared. This phenomenon, known as the Small Planet Radius Gap, points out a curious absence in the lineup of planet sizes, where we would normally spot planets of a certain scale, yet they're conspicuously missing. TOI-715b is a planet that intriguingly falls within this puzzling gap, much like a missing marble that you finally discover fits perfectly into the gap in your collection. Measuring about 1.55 times the size of Earth, it lands smack in the middle of this peculiar gap. For those studying space, TOI-715b is a treasure trove of opportunity to explore and possibly solve the mystery of why this radius gap exists. Its discovery is like finding a critical clue in our cosmic detective work, offering a fresh perspective on the complex process of how planets form and evolve. Explaining it this way, we turn the phenomenon into something more tangible and understandable. Finding that unique marble, or in this case, a planet like TOI-715b, marks a pivotal discovery for astronomers. It's a breakthrough that could help demystify one of the many puzzles of the universe, shedding light on the invisible processes and events that sculpt the vast cosmos. This discovery motivates scientists to investigate further into the origins and development of planets, providing potential answers to some of the most profound questions in astronomy. As we piece together the puzzle of the radius gap, our quest for knowledge propels us forward, exploring how discoveries like TOI-715b reshape the very methods by which we seek out new worlds. Chapter 6. Impacts on planet hunting. When scientists study far-off planets like TOI-715b, they call these planets exoplanets. Looking into TOI-715b is super interesting, not just because of the planet itself, but because it helps answer questions about lots of other planets too. This research doesn't just look at where these exoplanets are in space, but also tries to figure out how they got started and how the stars they orbit around affect how they change and grow over time. Let's break this down even more to understand why TOI-715b is so important for people who study space. Think of these planets as part of a big neighborhood in space. Some of these planet families are really close to each other, while others are more spread out and live further apart. By looking at TOI-715b, scientists can get clues about why planets end up in their specific places in this huge cosmic neighborhood. It's like trying to figure out why certain animals live in forests, but not in deserts. This helps scientists get a better picture of where to look for new planets and what kind of places these planets might like best. Going deeper, think of TOI-715b as a key that opens many doors. Studying this planet helps scientists understand the story of exoplanets, how they form, why they orbit their stars at certain distances, and how their living conditions change. It's like a detective putting together clues to solve a mystery, with TOI-715b giving important hints about where planets like to be and what kind of homes they prefer. It's not just about listing planets or marking them on a map. It's about getting to know their stories, how they came into existence, how they live, and how they relate to the stars they're close to. This bigger understanding could lead to exciting finds about planets we haven't even discovered yet, showing us the variety and complexity of planetary systems in the universe. Let's also think about how each planet grows and changes, kind of like how a seed grows into a tree. Finding TOI-715b in a weird spot, the radius gap, where planets are usually not found, is like finding a special tree thriving in a desert. This unusual situation makes scientists super curious about how it got there. They wonder if it's always been in this spot, or if something moved it there. Looking into this mystery is like figuring out the life story of that special tree, trying to understand all the events that made it what it is today. Moreover, the stars that planets go around are really important in how they grow, just like the sun is important for life on Earth. These stars can be calm and steady, or wild and unpredictable. TOI-715b goes around an M-dwarf star, known for being quite active, which could make living conditions tough for nearby planets. Finding TOI-715b close to such a lively star, but still within the radius gap, makes scientists want to check out how these star environments affect how planets evolve. It's similar to studying how different weather patterns affect plants' growth and survival in various places. The cool thing about finding TOI-715b is that it might help scientists understand why planets around M-dwarf stars can be so different. Some are rocky and dense, while others are gassy and light. This planet's unique spot gives scientists a chance to figure out why there's such a big difference, like trying to understand why some places have lots of plants and others don't. This deep dive into TOI-715b's unusual situation helps us get better at understanding how planets form and vary. It's part of a bigger quest to know the environmental factors across the universe that affect life and landscapes. Discovering TOI-715b is a big deal, more than just adding another planet to our list. It's like finding a key clue that can help solve many mysteries of space. This planet challenges what we think we know, pushing us to explore new parts of space. Every piece of information we get from TOI-715b makes our knowledge of the universe richer, helping us build a fuller picture of the vast and mysterious space around us. This research is about more than just counting planets. It expands how we see the cosmos, sparking wonder and excitement about what else is out there waiting to be found. Imagine TOI-715b not just as a dot in the universe, but as a light showing us new things to investigate and discover. Its existence makes scientists ask new questions and look into parts of space we haven't seen before. Every detail we learn from TOI-715b doesn't just fill a gap, it stretches the edges of what we know about space. This changes our view of the universe from just a place with stars and planets to a frontier full of unknown stories and secrets ready to be discovered. With every planet discovered, our hunger for understanding grows, leading us to the technological marvels that promise to unveil the universe's deepest secrets in unprecedented detail. Chapter 7: Revolutionizing Space Observation. Tech. We're on the brink of a huge leap in exploring space, looking at planets far from our sun, known as exoplanets. The James Webb Space Telescope, JWST, leads this exciting journey. Think of the JWST as a super strong telescope that lets us see faraway planets clearer and in more detail than ever. This amazing tool will change how we understand planets, like TOI-715b, by letting us peek into their atmospheres like never before. The JWST is especially exciting for studying the air of super-Earths. Super-Earths are a bit bigger than Earth, but smaller than giant planets like Neptune or Jupiter. By studying the air of these planets, the JWST can help scientists figure out if these distant places could support life. This means looking for water vapor, signs of life's building blocks, or other hints that a planet could be livable. Finding TOI-715b, a planet in an unusual spot, has sparked a lot of interest. It's like finding a new hint in the huge mystery of space, giving us ideas about how planets form and change. The JWST will improve our understanding of these processes. Its advanced tools are made to collect light from these far-off planets and analyze it to tell us what their atmospheres are made of. This step forward boosts our efforts to uncover the universe's secrets and possibly find life elsewhere. Imagine a telescope so powerful it can look at a tiny dot of light billions of miles away and tell if that dot has an atmosphere, what's in it, and if there's a chance it could support life. This is what the JWST offers to astronomers and scientists worldwide who want to learn more about distant planets like TOI-715b. Every new planet we study helps us inch closer to one of the biggest questions: are we alone in the universe? Each planet adds a piece to the vast puzzle of understanding space. TOI-715b is extra interesting because its unique place in space might give clues about planet characteristics and life's possibilities elsewhere. Looking ahead, the JWST is set to push the boundaries of what we know about the universe. Its detailed observations could show that some exoplanets are just right for life, expanding our ideas of where life could exist. The JWST's era of discovery isn't just about finding new planets. It's also about deepening our knowledge of the universe, feeling more connected to everything beyond Earth, and exploring the big question of our place in the vast universe. As we dive deeper into this new chapter, the JWST promises to uncover secrets of distant worlds with never-before-seen clarity. By studying the light from these worlds, we can learn about their air, temperatures, and maybe even life signs, marking a huge step in our quest to explore the universe. Each observation could revolutionize our understanding, bringing us closer to answering age-old questions about life beyond Earth and our place among the stars. This journey with the JWST is not just exploring space, it's a quest to grasp life and existence across the cosmos. This planet, TOI-715b, with its unique features and the knowledge it promises, reminds us why we look to the stars. It drives us to keep exploring space, fueled by our wonder and the hope of finding signs of life beyond Earth in the vastness of space. What do you think awaits us in our universe's vast, uncharted territories? Could there be worlds with life just waiting to be discovered? Smash that like button, subscribe for endless cosmic discoveries, and share your thoughts in the comments below.